Right now in the darkness above you, stars are dying. Not slowly, not quietly. In explosions so violent they briefly outshine entire galaxies. What you are about to watch is the true biography of a star, from its first light to its final catastrophic death. A star is a war. For millions of years, the crushing force of gravity tries to collapse it inward, while nuclear fusion at its core pushes back with the energy of 1 billion hydrogen bombs every second. Every photon of light you see from a star is the product of that war. Hydrogen atoms fusing into helium, two becoming one, each collision releasing energy as pure light that will take 100,000 years to fight its way out through the dense plasma to the surface. Our sun has been fighting this war for 4.5 billion years. Every second, it converts 600 million tons of hydrogen into helium. The energy released in that process is what you feel as warmth on your face. It has enough fuel to fight for 5 billion more years, but the fuel is not infinite. When the hydrogen at a star's core runs low, fusion slows. The outward pressure that held the star open begins to drop. Gravity begins to win ground it has been fighting for billions of years. The core contracts. As it contracts, it heats. And as it heats, it ignites the hydrogen in the shell just above it, creating a new ring of fusion surrounding the dying core. The extra energy pushes the outer layers of the star outward. The star begins to swell, slowly at first, then faster. Bloating, expanding outward for millions of years, until it has grown so enormous it would engulf the entire orbit of the Earth. A red giant. The temperature at its surface drops as the energy spreads across a vastly larger area, shifting the color from white to deep orange to red, barely recognizable as the star it once was. For a star the mass of our sun, this expansion is the beginning of the end. The star pulses. It sheds its outer layers in great waves. They drift away into space, cooling and glowing as the ultraviolet radiation from the exposed core ionizes the escaping gas. A planetary nebula. Rings of hydrogen and helium expanding outward in concentric shells of blue and gold and green, each one a pulse from the dying star's final moments. One of the most beautiful objects in the universe, and one of the most melancholy, the luminous ghost of a dead sun. What remains at the center is a white dwarf, the collapsed core of the star, compressed to the size of the Earth but still carrying the mass of the sun. So dense that a teaspoon of its matter weighs 5 tons, held up not by fusion but by a quantum mechanical force called electron degeneracy pressure, electrons refusing to be pushed into the same space. It glows white-hot from the energy of its collapse, and then it begins to cool. Slowly, over billions of years, it will dim from white to yellow to orange to red and finally to black. A cold, dark cinder drifting alone through space. Dead. But for stars born 8 times the mass of our sun or more, death is not a quiet fade into darkness. A massive star burns hotter, faster, and brighter than any sun-like star. It exhausts its hydrogen in millions of years, not billions. When the hydrogen runs out, it begins fusing helium into carbon. When the helium runs out, it fuses carbon into neon, then neon into oxygen, then oxygen into silicon. Each stage burns hotter than the one before. Each stage completes in a shorter time. Where hydrogen burning took millions of years, silicon burning takes days. The star builds up like an onion, with nested shells of different elements burning at different depths, each one racing through its fuel faster than the last, the whole structure accelerating toward a conclusion it cannot escape. And then the core produces iron. Iron is the end of the line. Fusing iron does not release energy, it consumes it. Iron simply accumulates at the core, an inert dead weight that cannot burn, growing heavier. When the iron core reaches a mass 1.5 times that of the sun, electron degeneracy pressure fails. The core collapses. In less than a quarter of a second, a volume of iron the size of the Earth implodes to a sphere 20 kilometers across. The collapse is so violent that protons and electrons are forced together into neutrons. The core reaches nuclear density, the density of an atomic nucleus, and stops. The rest of the star, billions of tons of matter that was falling inward, slams into this incompressible neutron core and bounces back outward in a shock wave of energy so immense it tears the entire star apart. A supernova. The explosion releases more energy in a fraction of a second than our sun will emit over its entire 10 billion-year life. For weeks, one dying star outshines 200 billion suns. It is the most violent stellar event in the universe. The shockwave from the supernova carries with it everything that was forged inside the star. Iron and nickel and cobalt, calcium and oxygen and carbon, gold and uranium created in the final moments of the explosion itself. All of it scattered outward at 10% the speed of light, seeding the surrounding galaxy with the material for future worlds. What remains at the center is a neutron star, 20 kilometers wide, containing 1.5 times the mass of our sun, spinning hundreds of times per second from the angular momentum of the collapse, firing twin beams of radio waves and X-rays from its magnetic poles. We see these beams sweep past us from Earth and call them pulsars. Some pulsars spin 700 times per second, the most precise clocks in the universe. For the most massive stars, even the neutron star cannot hold. The gravity is too great. The neutron star collapses further, past any known force that can resist it, into a singularity, a black hole, a point where the gravitational field becomes infinite, where space and time become so warped that nothing, not even light, can escape. The event horizon, the boundary of no return, is a perfect sphere of darkness surrounded by the distorted light of everything that came before. But here is what matters most. The iron in your blood was forged inside a star that exploded billions of years before our sun existed. Without that explosion, there would be no iron in the universe and no life. The calcium in your bones, the oxygen in your lungs, the carbon in every cell of your body. Every atom heavier than hydrogen was created inside a star that eventually died. And every one of those atoms was scattered across the galaxy by violence before finding its way, through billions of years and unimaginable distances, into you. You are not watching stars die. You are watching the process that made you possible. We did not just come from the universe, we came from inside a star.